That's very loud, isn't it? Loud before. My name's Penny Patterson. I'm just chairing today, and I represent the NACE community. In case you don't know NACE and I2I are putting together this CPD set of events across BETT. NACE is on stand, see I should know this, shouldn't I? B117. If you don't know NACE, it's an organisation which covers individuals, people passionate about technology, schools, other sectors, local authorities, support companies, technical companies, commercial organisations that are working on technology that makes an impact on children's learning. So if you don't know NACE, find out about NACE. It could be the organisation for you. But the important thing for today is the seminars, and I'd like to hand over to Peter, who's going to be talking about robotics and mindstorm programming, which I have to say is something that I'm fascinated in. I'm a secondary teacher, so this really suits me, and I hope you enjoy it as well. And hopefully there'll be time for questions at the end. So if you've got a burning issue as he's speaking, hold on to it, and we'll take those questions at the end. Over to you.
Thank you. Hello everybody. My name is Danielsson. First off, I'm going to talk about robotics and mindstorm program in school. The content of this day's lecture, first I'm going to be a little bit egoistic and tell you a short bit about myself. Then I'm going to talk about robots. I'm going to tell you about RoboCup Junior and what RoboCup is. I'm going to demonstrate how you program simple things in Mindstorm's program environment. And then I'm going to cover some bits of what me and my students have learned with robotics in school. I'm going to offer you some tips and tricks that I find helpful when you're working with this. I have also put together a tiny challenge that can be accessed. And I will try to end it with the question and answers if I have the time. So, come on. Yes, about me. I'm from Sweden. That's why you can hear my poor English. I live outside of Göteborg or Gothenburg, as you say in England. Right behind the R, in a little town called Öjersjö. I haven't been in Göteborg or Gothenburg for more than about half a year. I live there together with my wife and my 3 cats. I have a master's in education from Linköpings University in Östergötland. And my main subject is, in fact, the social studies, history, geography, and religion. But I've also read ICT, and that's how I have come in contact with robots. I've worked today in a concern or a company that's called JB Växthuset. And JB Växthuset has today 5 schools, and I'm working on JB Växthuset. You can see down in the bottom corner my boss, Kristina, who sits there. Thank you, Kristina, for being here and supporting me. Växthuset is a small school. We started the last semester and we have about 140 students today. I think in JB Växthuset we have about 1,000 students. I'm not exactly sure about that. So, today I'm going to mainly talk about robots. And when I sat and write this presentation, I thought, what is a robot? And one of the first things that comes to mind when I think about robots is this one, the Terminator, the evil presence from the future that are here to destroy us all. Oh no, very bad. But this is more a fiction thing, and it's from our imagination, it's from pop culture. When I were working with this, I also come to this. Do you know what it is? Nobody knows it. Yes, it's a robot vacuum cleaner. The most evil robot today. They take away all the fun in cleaning in your home. They can move your lawn, and they can do lots of practical stuff. And be really helpful to us. Another thing that popped to my mind is this one. Toy, a robot dog. Maybe practical if you're allergic and can't have a real dog, or maybe practical if you like robots. I remember when I was small I had lots of robots. not so advanced as this one, but they were surely fun. But the focus of this day is about robots in education. This one is called an iCat. I think it's the company Philips that has built this one. It's a socio-emotional robot that can learn students to speak languages. I read a study about this one, and it taught the students the language Tokipona. It's an imaginative language, and the RoboCat can be happy, it can be sad if you don't understand the language. It can support you and say, you're good, or try again. Very fun robot. I haven't tried to practice with it, but I surely would if I could. Another robot that comes to my mind is this one. I don't know if you have seen it, dancing the Gangnam Style out here on BETT. It's a fantastic robot. The Now is the main robot of RoboCup Junior, and it's kind of a trademark robot. It's very advanced, it's bipedal, so it can walk about, it can fall and raise itself up. It has fine sensor in its eyes, so it can track your face, it can talk, it can understand who you are. I would really like one of these ones, but they are about 10,000 pounds, so I can't get one right now. The robots that I'm working with are these ones. These are Lego robots. They aren't so expensive, and they are very practical to work with when it comes to students in secondary school. Let's go through and look at them. When you buy a Lego robot, you can build as many robots as you would like, or as many models as you like. These four are the basic ones that you get the script how to do. On the first one, we have a cannon robot that is driving around and shooting at you. Not so very nice, like a Terminator. The second one, to the right, top, is more like a fabric robot. It can sort orbs and bricks by color, and if you evolve this robot, it can actually solve the Rubik's Cube. So it's more smart than I am, because I don't manage it. In the left corner, we have the Alpha Rex, a bipedal robot that isn't so flexible, but it can move around on its own and do kind of bad Gangnam Style. We can also build a Robogator that attacks people and try to bite them very nasty. It's kind of fast too. One of my students built one, and it was really fun. The robot's parts is what makes it a real robot. In the center, its brain or its heart, we have the NXT brick. It's connected to different sensors and motors that makes the robot function in our environment. This one is the motor. It's absolutely crucial for the robot to be able to move around. It has to do stuff for us. But this motor is, of course, in need of the brain and also by other sensors. Like this one, a touch sensor. It's like the skin of the robot. When the robot gets in touch with something, the robot knows that, oh, I have bumped into somebody. It's an object in the way. I have to do something other. Another useful sensor when you program it is this one. It's an ultrasonic sensor. It's like a bat. It sends out a signal and it bounces off a wall or an object, and the robot understands, oh no, there's something in the way, I have to drive another way, or oh, there's something here, I have to go and check it out. So it's kind of a vision-like, but the robot has another kind of vision, and it's this one. It's a color sensor. It can see difference between light and darkness. It can also see difference between red, yellow, blue, all the colors if you are good enough to specify them. This is what makes the robot practical for use with secondary students, that it gives a lot of options when you're working with it. I have mainly worked with a challenge called RoboCup. RoboCup in Sweden has the last year been represented in Blekinge, in Karlshamn, right beside where I live. Today I think it's going to be in Linköping, where I went on university. RoboCup is actually divided into two parts. We have either the RoboCup Ordinary, or we have the RoboCup Junior. The Ordinary RoboCup is for students on university level, and the RoboCup Junior is for age, I think it's 5 to 19 years old. The Junior part is divided into separate challenges. We have the dance, as we can see in the top corner. The dance is actually separated into two sub-genres, and we have one that is actually a dance between the robots and the kids that has programmed them, and the other one is kind of a theater, when you program the robot to tell a tale. It could be a classical folklore tale, or it could be a new one that the students has built for themselves and designed, written, and so forth. Another popular contest is the Robo Soccer, and I think that could be good in England. That loves soccer, I think. I'm not a soccer fan, and I don't really have much experience in this one, but the robots are kind of fast, and they are driving around trying to score and defend their goals. And the rescue part is the one that I mostly work with, and it's kind of a scenario where a disaster has struck for the humanity. It's kind of, if an avalanche has come and fallen over some little village, the robot has to go in, it has to locate the humans that are the victims, and they have to save it. To do this, the robot needs to follow a line, marked as the black line we can see on the lower picture. It has to be able to go around objects that has been placed in the way. If there is a gap in the line, it's as if the snow has fallen over the road, the robot still has to continue and doing its quest. At the top of this challenge, we have a victim, a human, as should be represented by a Coke can or something like that. The robot has to pick it up and put it in a safe zone, so that a shopper or whatever could come and collect it. It's really good, as it's a very diverse challenge. Rescue is also has a second part called Rescue B for older students. And that's more kind of a maze variation of a rescue. They don't have a line to follow, they never know how the maze is supported and where things are. And the robot needs the ability to find the heat of the victim. So I think it's about 37 degrees Celsius, so it could sense the human body. The RoboCup is often taking place in different parts of the world. Last year it was in Mexico City, the year before it was in Istanbul in Turkey, this year I think it will be in Europe in Eindhoven. So it really gets the students a chance to travel alongside the world and meet other programming kids. Now I'm going to demonstrate how you program a robot to be able to participate in RoboCup Junior. So let's see if we can start the Dinosaur program environment. Here, as we can see, we have first two fields. The one on the left is the different models that I talked about earlier. And if I want to build them, I can simply click on them. So here we have the Robogator. I press go. And my robot is now divided into 4 parts. So I can start with the jaws and start. Ta-da! If I zoom out or zoom in, I get picture by picture. As ordinary Lego builders, you know what this is all about. And if you have a PC or a Mac, no problem. The student can build, they can create, and they learn lots of engineering skills by it. If I would like to program my robot instead, when I have built it, I go into this environment, create new program. I can title it, and there we are. This program environment is used in a bigger form in many different ways. I think the Swedish Air Force JAS has been tested the motors in the same environment but in a more advanced form. This kind of environment are practically used in industry and other things as a kind of simple way to program stuff. The best thing about this, in my opinion, is that the student don't need to know code lines. It's much quicker and it's much more intuitive for them to learn with this motor. We have different colors that represent a lot of stuff. We have different choices down here, and it's basically kind of a way to understand how to move the robot or how to do stuff with it. If I start with this one as color presentation, you see a lot of sensors that are in the same category. I will start with the simple thing in this program as to make the robot move. Then I just have to drag one of the blocks, and you see down here, my programming option evolves for me. I can use things like deciding which port the robots are going to have active at the moment in this programming block. I can decide what direction the motor should be spinning. Is it going forward, backward, is it going to stop? I can also steer the motors if I have two chosen at the same time. I find it's mostly easy if I want my robot to turn around to just switch one off or to change between them. That makes the robot much more flexible if I'm building, for example, a robot on wheels to drive around. By this program, I also have the ability to choose the power. Do I want a Ferrari here, or do I want a snail robot? A snail robot could be handy if I want it to be very exact. A fast robot could be good if I have a limited time to do a quest with it or something like that. I can also show how long the robot should do this. I'm not a mathematician. I'm more working with time. That's my mainly choice. So I use seconds. I also have the ability to choose rotation. That means that the motor takes one spin. I think it's kind of hard to work with. I can also work with degrees or with unlimited speed or duration. The last thing we have here is next action. When I have this one chosen, the brake, the motor brakes and stops, like we're putting the brake on the car, we want it to stop. Or I can choose coast, which means that the robot is using its movement ability to slowly get to stop. This one program now, I have a robot that is driving forward in 1 second. Very fantastic. If I want my robot to swing around, I choose the same option, but I take off one of this motor, I still keep it going forward, and I can choose that the robot is able to swing around for 2 seconds. That will make probably the robot to turn around. Kind of practical. This is the easy part. This is the fun part where the students learn and they can test and they can try on different courses. And it's a lot of fun, it's a lot of practical thinking. The more advanced things we're going to look at today, we don't have time to look at so many things, but one of them is in this block called loop. As you can see in this loop, it has the eternity symbol. It will go on and on and on and on and on forever. As you can see down here, we have other options now presented for ourselves. We have the option forever, but I can change this to a sensor option. And now I have all my sensors. You remember what I was going through earlier. This one, the touch sensor, go on until something presses the touch sensor. So for this to at all work, I need to have a motor inside this loop. And now I have to set this from rotation to unlimited. Now the robot is moving forward with its A and B motor for 75 speed, unlimited, until something is pressed against it. Then I want my robot to move forward again. That doesn't sound smart at all. I probably would like my robot to back away as it has hit something. So then I just change this program so that the robot reverses a bit and it backs away and turns around, going in another direction. This programming is interesting because it's segmented And the students learn that everything has to be in order. First the robot needs to move forward, then it has to be pressed, then it can do its next action and its next action. But then this programming is finished. And that's not so fun. So I can enhance this another step by taking another loop. And I can put my first loop in this, and I move my other blocks inside it. And ta-da! When my robot has done its first loop, it will be in another loop. So it will do the same over and over again. So I can set it inside the room and it will go on forever until its battery breaks. If I'm going to have time with my questions and answers, I think I maybe will be forced to go through to the next part of my presentation. I really recommend this program as it's very, very easy to learn. One of the things that I have seen when I'm working with this, and it's not only me, I've done it with a colleague of mine, and we have trained the students to work with this very much, is that the students learn a lot about logics. They need to learn when things are going in which direction, when the robot is doing this, when the robot is doing that. The funny thing is also that the students that are good at math are nearly always excelling in programming robots. The student that doesn't like math, surely enough likes to program the robot anyway, and therefore gains a push in the math ability, which has been very interesting to see. Another skill that students learn is engineering skill. In Sweden we have a subject called technique. I was struggling to call it technique, so engineering is a better part of it, or a better word for it. And the engineering is very important when you're participating in RoboCup, as the students has to build their own robot. I can't give them an explanation, build it like this or build it like that. They have to decide all for themselves how to do it. It's the same thing with the logic. They have to make their own program. I can give them advice, I can give them tidbits, but they are the ones that have to decide and choose for themselves. Collaboration is also a very big part of this, as I see students work on their own, and that doesn't all go well for them. When they get together in a team, they are almost always better at this. So the collaboration and the designation of team tasks is very important when you work with this. You need to have somebody that is lead programmer. Somebody has to be the lead builder. Somebody has to be the team captain. Somebody has to document the work so they can send it to me and I can review what they are doing when I'm not exactly at their post and looking at what they are doing. The benefits when working with this is that it's both practical and theoretical in the same time. The students don't only sit and think about themselves. They actually have to do stuff with their hands, they have to build, they have to program, they have to take the robot away and test it, and they have to look at the robot, they have to assess what is the robot doing, how is it doing it, and why is it doing what I want. It's also a lot of trial and error. So if the robot doesn't work, what do we do? Are we going to sit down or are we going to go back and do another thing, try new ones? Of course we have, and the student has to learn this as it's an important skill in life, I think. It's also easy to learn, but it's very hard to master. You can learn the basics in surely about 2-3 hours, but to be a master on this, you have to spend an eternity almost, I think, at least with my students. But it's so much you can do with it, so it's only for the real geeky to be the masters, but it's surely cool. Another thing that is good with this, it lets the students be creative in my department or in my areas. And usually I don't have creative stuff in the engineering course or in my IT in this kind of way. And they also have to use their imagination. They can imagine what they want to build and how it should look and how it will work. And if it doesn't work, then trial and error. We have to practice, we have to go back, and we slowly get better and better at it. Some of my tips and tricks is one of the books I came across in this field. It's called the Lego NXT 2.0 Discovery Book, and it's written by Lawrence Walk. It's a fantastic book which gives you a lot of ideas what you can build with a robot, and it also get you ideas how you program the robots in a bigger sense of way. If you have tried Mindstorming and feel, oh, it's boring, my students already are pros at this, you can go on to a Robot C program. I think it's a free software for 30 days, you can try it, and the students then has the ability to actually write code. And I think in Robot C you also have virtual reality that the robot can drive around and test its capabilities. So that's really cool and interesting. There are also, of course, a lot of online resources. One of the best that I have used is the nxtprograms.com. It has many building models, it also has many programs, and when you download the program, it's not only a program, it's also a described program. So the persons who have done this has described, you should put this sensor here, you should put this logic here, because of. So the students, they can assess, they can pick it together, and they can learn what to do. We can't forget either the Mindstorm's own Lego side, as they offer challenges, they are offering good stuff to think on when you're working with this. I think if you haven't worked with this, you should take a little second thought, because this winter the new robot is coming. I were down at Lego yesterday and looked at it. It looks really awesome. It will be a better version of this, or at least a different one with other capabilities. It has another program environment. So I'm not so sad that I already have the older one, but I surely would like a new one to test and to learn. It's always good to learn more, but if you don't have a Lego robot and you have time to wait, please think. I'm putting together a challenge that everybody who is here could participate in if they want to. I built a practice course in my classroom for this occasion. I used a bit of white paper and a lot of iPad boxes that I have laying around, not doing much but being there for me to use. I set a couple of conditions. I want to have a robot that is able to move on its own. It has to be autonomous. We could start the robot at any of the spots that we see, either in the down corner or in the top. The robot will be able to move around by itself with an ultrasonic sensor and a color sensor. The thing that the robot shouldn't do is either hit the walls or going into the black area. That's the doing things and the things that the robot should not do. I've specified the size of the course, so it's a little math challenge too, to build this one. And if you would like to participate in this challenge, please feel free to mail me if you want this picture or if you want my presentation. I will mail it back. You can show it to your students, you can build a course, and you can build a robot that has the ability to do this course. If you manage to do it, then you send your program to me and my students. You also send a specification of what kind of robot you have done. My student will try to build this robot, and we will try it at our course. If it works, we film it, we send it back to you, and by that time, maybe you have built your own more devious track, so we can try to program it too. And in that way, we can kind of create a bigger set for the students to learn and to cooperate, not only inside my school, but in the whole world. Now I think it's time for some questions and answers. The thing you should know about me is that I'm quite deaf, so if you're going to ask questions, you have to use a very big, loud voice.
There's a microphone going around.
Okay, is the microphone going around?
Have you got any questions, comments?
When you're designing a program, can you actually basically name each section of the code so you can reuse it, copy and paste it?
You can create your kind of own programming boxes if you would like. You can do a program that is a line follower. You can do an eternity auto-sensoric program, yes. You can design it by yourself.
How many contact hours do you have for your course, or how many contact hours do you typically have, or would you suggest for a month?
How many robots?
No, how many hours throughout the semester or throughout the year?
Okay,
What class periods are out?
I think I have about 2.5 hours with every class that I'm teaching per week. So, sorry, I'm not good at math, but take it to 2.5 by 40. Could that be 80, 100 hours maybe? If that wraps it up, it's okay. Another question.
My question is, how much investment would be needed if you want to set up new?
Can you please speak?
How much amount of investment is needed to set up a lab with all those facilities?
Yes, that all depends if you have computers in your school, because that's one of the things that is kind of sad. We are an iPad school, but we have to have a computer lab. So I think I were able to buy computer equipment for, could it be £6,000 maybe, and then the robots, I think I bought for about, could it be £3,000. But the computers is available to all the school, and they are practical in many ways. And the robots, I tend to use them in every class for every year. So I see it as an investment that is carried out for many, many years.
And what age or what class the students are actually can participate in this?
I didn't get that.
No, what is the age of the students minimum?
My age of the students, they are secondary schools, so they are between can be 12 to 15. But I've also tried this with younger students, about 9 years old, and they love it too. But I don't teach them in regular ways, so, but when I have the chance, they love it.
Any further questions?
Okay, thank you very much. It has been an honor to be here and to speaking for you. It's the first time, and it's really crazy I've done this. Thank you.
I noticed that Petter put his email address on the bottom